I'm Anil Kumar. Welcome to my series on probability. We'll discuss conditional probability in this particular section. When I say conditional probability, we'll be given that some condition has been met and now find the probability of an event which happens. The formula which is normally used is given here. We'll actually discuss this topic with the help of 6 very common examples. These 6 examples have been modified into multiple choice questions so that they can help you prepare for your own test. I would like you to pause the video, copy these questions, solve them, and then look into my solutions. Now, question number 1 here is regarding a computer system which crashes or hangs, and we need to find the probability that the system crashes when it is given that it hangs. So that is how it is a conditional probability question. Then we have question number 2, where we are given probability of event A, probability of event B. We are given probability, conditional probability of A when B happens, and we need to calculate the union of probability of A and B. Question number 3 is we are given probability of A when B happens, and this time we are given probability of A union B. We need to find probability of event B. So that ways it will give you good practice on this topic. Question number 4, in this particular situation, we are going to use a different approach to solve conditional probability question. So it will be very interesting to see how, without using the formula, we can find solution of conditional probability questions very easily. Question number 5 here gives you an alternate to the formula itself. We need to show that probability that A happens when B has occurred is probability of A divided by probability of B times probability of B when A occurs. Now this is a very useful formula which can be used many times. Then we'll have another question where we are going to solve using a tree diagram. So tree diagram is an excellent approach for solving conditional probability questions. So that will give us a very good overview on this particular topic. So let's begin with the basics and then solve all these questions. Let us understand the formula for conditional probability first. If A and B are 2 events, then probability of A given that B has occurred is written as P, probability of A given B has occurred, is equal to probability of intersection of A and B divided by probability of B. Now let's look into this scenario. Let's say this is our sample space, and in this sample space we are talking about 2 events A and B, right? So let's say this is the event A, and let's say the event B is this one. So we have event A and B, and this is our sample space S. Now when I say probability of A when B has occurred, it really means what? Now probability of A when B has occurred, that means probability of B is this. So B has happened. So that becomes my sample space for conditional probability. We are saying that this event B is already done. Now find the probability of A happening. So probability of A happening will only be the intersection part, right? So this part. So that is what we are looking into. Perfect. So I hope you are getting the concept. So basically in this what happens is that our domain, or you can say our sample space, is redefined. Since we say that B has occurred, right? So when we say that B has occurred, that means we are talking about this sample space. Do you see that part? So this is very important to understand. And now let us try to understand how to derive this formula also, right? So we can say that probability of A when B has occurred is equal to this part, right, which is intersection of A and B elements, right? So it is number of elements in A intersection B divided by total number of elements in B, right? So that is how you could actually see it. Now if I divide both numerator and denominator by number of elements in sample space, what do I get? That is to say, if I divide this by number of elements in sample space and also number of elements in B by number of elements in sample space, then what I get really is probability of A intersection B divided by probability of B. So that is the formula which we have right there. Do you see this part? So I hope you got insight to the formula, right? So that is how it is linked. Now, once you have understood what this formula is, let us realize that we could actually solve the questions by different ways, understanding that the sample space has been changed to the event which has occurred, right? So this thing comes in the denominator. Now let's take up the examples one by one. Question 1. My computer sometimes hangs while uploading videos. At times, there is a risk of system crash also. It is observed that probability of computer hanging in a period of an hour is 2%, while the chances of computer hanging and system crashing in that hour is 0.5%. If the computer is hanging, what is the probability that the system will crash? Right? So what we are given here is dependent or conditional probability. We can define the events as my computer sometimes hangs while uploading videos. So probability of event A. What is event A for us? Event A is the event of system hanging. So it says it is observed that probability of computer hanging in a period of an hour is 2%. So probability of A is 2%. So probability, actually I should write, probability of A is equal to 2%, which is A is being defined as system hanging. Now, probability, while the chances of computer hanging and system crashing, so B is system crashing. So what we are given here is that probability of A and B, that means system is hanging and crashing, is 0.5%. You get an idea. So what we are given here is that the probability of system hanging is 2% and that of crashing is, both of them happening, is 0.5%. Now, if the computer is hanging, that means if A has occurred, what is the probability that system will crash? Correct? So we want to find probability of B, that means system will crash when it is hanging. You understand how, correct? Now this is given as probability of intersection of A and B divided by probability of B, or probability of A, what is there in the denominator, right? This A. So in our case, we are given this as 0.5 divided by 2, or is equal to, you can divide this and get 0.1 1 over 4 I can write it. This is half, which is 25%. Correct? So option A is the right option. So I hope you have understood the concept of conditional probability with this example. Now let's move on and take up some other questions. Question number 2. Given probability of A is 0.6, probability of B is 0.3, and probability of A when B has occurred is 0.2. Calculate probability of A union B if A and B are not mutually exclusive. That means there's something common in between, right? Okay. So let's begin with our formula, which is probability of A when B has occurred can be written as probability of A intersection B divided by probability of B, right? So this thing comes in the denominator. That is a straightforward relation. Is that okay? Now in this particular case, we are given probability of A intersection B. We are also given probability of B. So we can find the intersection, right? So 0.2, let's write down, 0.2 is equals to probability of A intersection B over probability of B is given to us as 0.3. So cross multiply, you get 0.2 times 0.3 equals to probability of intersection of A and B. That means both happening, which is 0.06. So that is the probability of A and B happening, right? A and B. Now we need to find what is the probability of A or B union. So probability of A or B is probability of A plus probability of B minus probability of A and B, right? Because since that is counted twice. So we know probability of A is 0.6, probability of B is 0.3, and we'll take away 0.06. That gives us 0.9 minus 0.06, which is 0.84, right? So 0.84 is option D for us, so that is the right answer. So I hope that is absolutely clear. So here we have used both the concepts. One, probability of A and B, and second, probability of A or B. Now let's move on and take up question number 3. Given probability of A equals to 2 over 3, probability of A when B has occurred is 1 over 5, and probability of A or B is 4 over 5. Find probability of B. 4 choices are given to you. Now, we know that probability of A when B has occurred can be written as probability of A intersection B divided by probability of B. Right? So from here, we can write probability of B. So cross multiply is equals to probability of A intersection B divided by probability of A happening when B has already occurred. So that gives us one equation. So let me call this as our equation number 1. Now let's look into the OR part. We are also given that probability of A or B is 4 over 5. So what is probability of A union B, which is A or B? It is probability of A plus probability of B minus probability of A intersection B, correct? Now, we know probability of A intersection B from here, so we could actually get the values right from here. Okay, so probability of A intersection B, let me rearrange this formula and say probability of B times probability of A when B has occurred is equal to probability of A intersection B, and this is given to us as 1 over 5. So this is 1/5 of probability of B which is equal to probability of A intersection B, correct? So I will replace this here. We'll get equation in terms of probability of B, right? Probability of A union B is 4 over 5. So let me write 4 over 5 here. Probability of A is 2 over 3 plus probability of B we want to find. And we got probability of A intersection B in terms of probability of B, which is 1/5 of probability of B, correct? Now we can clearly find it. So we have probability of 4 over 5 take away 2 over 3 is equal to probability of B minus 1/5 probability of B. So that is taking common denominator, which is 15, we get 12 minus 10 equals to 1 minus 1 over 5 is 4 over 5 probability of B. This gives us 2 over 15, and we can cross multiply. We get 5 over 4 equals to probability of B. Now this can be simplified. That goes 3 times. This goes 2 times. So we get this as 1 over 6, right? So option D is the right option. Correct? So we have to rearrange 2 different formulas. We have learned both conditional probability formula and probability of A or B. So when you combine them, you can solve such questions. I hope it makes sense. Now here is question number 4. We are saying that 2 balls are selected at random from a group of 4 red balls and 2 blue balls. Find the probability that both balls are blue given at least one is a blue ball, right? So we are given that at least one is a blue ball. Now to solve such questions, we could actually use strategy which we have used for dice. So let's say we have 4 red balls, and let's say 4 red balls, and we have 2 blue balls. So we are selecting twice, so let me write 2 times. 2 blue balls. Let me write B here, blue balls, right? Now we are also given here a condition that at least one is blue. So if you go for the combinations, then here we have all reds, right? So these are all reds, correct? We will get blue and red in this combination, right? So here we get blue-red. Here also we get blue-red. But these combinations are both side blues, right? I hope you understand what I'm trying to say here. So if I have this point, we have 2 reds. So first is red, the second is also red. Here again, both are red. Here again, both are red. So likewise, all of them are red, right? So, but in this case, the first one is red. The second one is blue. You get an idea. Here also, one is red, one is blue, right? So, but in these cases, we have both blues, right? This is one blue and the other one red. Blue, red. Do you see that? Since we are given at least one is blue, that means we're looking into a sample space of this, right? So when we say at least one is blue, then what is the probability that both are blue, right? So we want probability of both of blue. We know at least one is blue. That means in our sample space, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 options Out of these 20 options, 4 are with both blues. Got it? So from here, we could say it is 1 over 5, and so the answer is A. You see that? So we have solved this question without using any formula. That's the beauty of it. Now here is question number 5. Show that the probability of A when B has occurred is equal to probability of A divided by probability of B times probability of B when A has occurred. So let's work on both the sides and see what result we get. So when we are saying for the left side, we have probability of A when B has occurred. As you know, the formula is probability of A and B, their intersection, divided by probability of B, correct? Now on the right side, we have, let me write down right side here, we have probability of A divided by probability of B times probability of B when A has occurred. So that would be probability of B intersection of A divided by probability of A, correct? Now from here, we know this can cancel. So we could write this as probability of B intersection A divided by probability of B. Now what is probability of B intersection A? It is same as probability of A intersection B, right? So it could be written as probability of A intersection B divided by probability of B, correct? So we see that both are same, right? So this is what we began with. So they are both equal. Perfect. So this formula can be actually interpreted in many different ways. Now let's move on and take up the last question, which is question number 6. A family is chosen at random from a set of all families with exactly 2 children. Find the probability that the family has 2 boys if it is known that one child is a boy. Second condition is a family has 2 boys when it is known that the first child is a boy, right? The first is a boy. Here one child is a boy, correct? So in such cases, what we can do is that we can make a tree diagram. That will be a good approach. So the probability of having a boy and a girl is 50-50. So let's say we have a boy or a girl, and the second time it could again be a boy or a girl, right? So the result here is that we could have 2 boys, we could have a boy and a girl, we could have a girl and a boy, or we have 2 girls. Since we have families with exactly 2 children, right? So it's important to know we choose at random from set of families with exactly 2 children. So that is the combination. Now we need to find the probability that, case A, let's take this. The family has 2 boys if, so we are looking for 2 boys, which is only one combination here, if it is known that one child is a boy. So out of how many? Out of 3, right? One child is a boy, right? Both could also be boy. Perfect. So the probability of the first one is 1 out of 3. The conditional probability restricts the domain. Now the domain or the sample set is not all 4, is the one where there is at least 1 boy. You are getting an idea. One child is a boy, correct? Now let's look into the second one, which is the family has 2 boys when it is known that the first child is a boy. Now in that case, we are restricted only to these two cases, the first child is a boy. So for that we have only two cases. Out of those cases, having two boys is only one. So here the probability is 1 out of 2 or 50%. Do you get an idea? So at times we can also solve very easily conditional probability questions using tree diagram. So what we have learned here is how to approach any question based on conditional probability. You should adopt the method which is best suited as per the question. I hope that helps. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.